Okay.
Was placed in a flask containing
That's
yellow
sodium.
chlorine gas.
Sodium. Small piece of sodium.
The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine.
Chlorine's
The
that green
reaction
gas
will
you
be
see.
initiated by adding a drop of water to the sodium.
All right. Now, why did I show you that? Because backlight on? Because that's what we're going to be doing in this chapter. We're going to be doing reactions. Now, I showed you sodium plus chlorine. You saw the green gas in that jar, and you saw this little piece of sodium. I'm not going to do that one myself because I would have to have a cylinder of chlorine gas. But I am going to do a bunch of demonstrations for you over the course of the next couple of chapters, next couple of days, I should say. Today you're going to see one, quite a few tomorrow. And there's going to be all these demos in a lab about this because we're finally at a place where we're talking about reactions. So you're going to see some reactions. You're actually going to see them happening. And then you're going to have to write the stuff that tells me about them. I use salt as the first one because guess what? We just had that stuff on salt yesterday, right? We had a video on from Modern Marvels on salt, right? So I basically wanted to get show you an example of each type of reaction that we're going to see, all right? Today, in this chapter, we're going to be talking about reactions, how they're classified, and how we write them, and how we balance the equations once they're done. I don't normally do this. I can't show it to the video, to the camera, but I'll show it to you off screen here. This is the test. There's no backside to this test. That's the entire test for this chapter, and you will have this test by next week, by Thursday, before Christmas. Okay, you will need this test, considering the grades in the last one were not very good. I just graded those. Last class, I gave their grades back. 80 was the average. There were 50s and 60s and 70s galore on this test. There were also, obviously, high 90s as well, which you'd expect. But I was very disappointed in a lot of the answers I got from some of those parts of the test. I mean, it doesn't make any sense to me. One thing that I think contributed to it was having a snow day. So it was one day in between the review and the actual test, which I think hurt you guys. Shouldn't have. Some of the mistakes were, I mean, it's not like we just did it one day. But either way, everything you had to do last chapter, all of that stuff has not gone away. If you couldn't name those compounds last chapter, that's going to be just one step in this chapter. You're going to have to write all the formulas first before you can even finish balancing the equations. Okay? So that's what I'm going to teach you how to do today. It's not going to take me that long for today. I have a very small, we have 2 periods, but the second period we're going to watch. Oh, you guys already saw the video, right? Yeah. I just realized that we have 2 doubles in a row. That's right. It's weird. All right. Well, we actually will have to do some more notes on that. I was thinking the opposite. I was thinking this class had a single, and the other class had a double. But yeah. All right. Either way, let's get through the first type of reactions we're going to talk about. But before I even begin the different categories, I want to first just mention what a chemical reaction is, talk about what it is, and what we're going to be doing here. What a chemical reaction is what you just saw in that video, what you're going to see at the end of this period. It's when you add something to something else and you get a new substance. All right? That's a chemical reaction. So what you're seeing happen when these chemicals actually combine is the chemical reaction. What you're going to write down on paper is what? A chemical equation. You're going to write down the equation. You know, it's been a long time since we used the word chemical reaction. But I told you nothing goes away here. Chapter 1, I think that one of the first concepts we have, certainly in the first week of school, we did the difference between physical versus chemical changes. Remember? We had a lab on physical versus chemical changes. Okay? You know what another name for a chemical change is? A chemical reaction. On that day, when I talked about chemical changes and the evidence for chemical change, I did a bunch of demos. I even wrote their equations on the board. I didn't write them on this one. I wrote them on this one over here, remember? And we didn't, at the time, didn't really know most of those things. I used simple things like salt and sugar. I burned sugar. But now, I'm going to give you, on this sheet, you can see it, I'm only going to give you half the equation. You'll have to tell me what you get from adding this to this. Okay, that's your job. You're going to have to complete the equation. All right, and that is called the chemical equation. Reactions are what you see with your eyes. Chemical equations are what you're going to write with your hands, what you're going to write on a piece of paper. You're going to use numbers and symbols for the elements, put them together, and tell me what actually happened in that reaction. That's the job. That's your job. And that's all I have to teach you this chapter. That's why it's such a short chapter. That's why I can actually have the test, all right, before Christmas, even though we only have 1 week. All right, now I'm going to give you some general information about reactions first, and then I'm going to talk about the 4 different types. We'll only get to 1, maybe 2. Like I said, I was let's see how we do this. I was thinking we had a single, not a double today. But we'll definitely get through this first class, then we'll figure out what we're going to do next. I have those makeup tests to give too in here. All right, in general formula for a reaction looks like this. The guys on the left are called the reactants, and the guys on the right are called the products. That makes sense, right? You're reacting things together, we call them reactants. The stuff that you're producing, we call the products. Does anybody know how we read that arrow? Anybody know what word you would use? Reactants, like sodium plus chlorine, begins with a Y. Yields, yeah. Sodium plus chlorine yields products. So you read that arrow as a yield sign. Yields. So the guys on the left are called the reactants. The guys on the right are called the products. Some generic information about reactions. Now, I want to give you 3 steps for writing any reaction you want to write. There's 3 things you have to do. At the end of this board, and there's a couple of little reminders on the next board, is basically the end of the notes for the chapter. The rest of this time is going to be spent doing examples. I'm not kidding. Today's the first and last day, pretty much, of notes for the chapter. Doesn't seem right, but it is. Because we're simply going to be practicing these 3 steps over the course of the next 5 days. All right? Now, I want you to skip 2 lines for this example. Write example right underneath it, and then leave 2 lines for the example. Leave 2 lines for this example. So, because I'm going to use the example as I give you the steps and do one. I'm going to do exactly the one you saw a minute ago on the video clip. Okay? So skipping 2 lines for this example, the first step you have to do. I will give you so much. I will give you this much. Here's how much I'll give you. All right? You could write this into those you're leaving blank. I'll say sodium plus chlorine yields. That's how much I'll give you. Your first step will be to complete that word equation. Okay, so that's what I give you. What's in blue there is what I'm going to give you. So let's do this first step. I'll do this in red. Now, the nice part about this simple equation I'm using here is that it's a common sense one, right? I don't think anybody's going to get this wrong. When you put sodium together with chlorine, I've used that as an example probably for the past 4 straight chapters. Since we first started talking about electrons, I use sodium chloride. The periodic table, I used it. This past chapter, I used it, and now again I'm using it. What's sodium and chlorine going to come together to make? Sodium, what? Chloride. Okay, that's what you would have written on the test yesterday. I think everybody would have written that. I don't think anyone would have gotten sodium chloride wrong if I had it there. I didn't have sodium chloride on the test, but I had one's just about that easy. Okay, so there you go. That's your first step in red. We completed the equation, made sodium chloride. What's my next step? Well, next you're going to simply write underneath each one of those the correct formula or compound. Guess what we did all last chapter? Practice that. Didn't help some of you because it wasn't just the oxidation numbers you guys got wrong. A lot of you guys forgot about oxidation numbers. Screwed that up royally. But you know what? That was only worth 8 points of the entire test. That doesn't explain the 60s and 70s I saw. You didn't get a lot of the simple naming and writing formulas correct. All right? Let's see what we do here. Let's use black for this part, okay? What's the correct symbol or formula for sodium? Na. What's the correct symbol or formula for chlorine? No. Already we're wrong. Now, I didn't have any insight on the test, but it's not Cl. It's what? Nope. That's what much worse to call it ClO. That's chlorite.
Cl2.
Cl2. He is one of those diatomic elements. I didn't have that on the last test, so that didn't cost anybody any points, but it will show up a lot of times here. If he's by himself, chlorine and all of the Brinkelhoff, all of those 7, N, O, F, Cl, Bri, and H, all of those 7, when they're by themselves, have to have a 2 next to them. I explained that before, where diatomic elements come from. Saw it before, more than once. They are so reactive, they want to have an octet, they're going to share with themselves. We even did electron dot notations for some of them. All right? Now, here comes the best part, and the first place where you see mistakes. Okay? What's the formula for sodium chloride? Everybody look up here and tell me, what's the formula for sodium chloride? What am I going to write? You sure? It's NaCl? Maybe this time it's different. What's the problem with just writing NaCl? Well, Na's got +1, Cl's got a -1, so it's NaCl. What's the problem with that?
Because you got 2.
Well, I got 2, so I'll just make it 2 over here, right? I'll just put a 2 there, right? That's what you'll want to do. That's exactly what you'll want to do, but you can't. NaCl is correct. That's the correct formula for salt. It doesn't change because I want it to be different. But you will do that on the test and on the worksheets, guaranteed. You will say, well, there's 2 chlorines over there, so I got to put a 2 over here. So you're saying if you do that, let me just explain this. Everybody watch. You're saying if you put a 2 down here, that now, all of a sudden, this guy's gaining 2 and he's losing 1 and he's quite happy with that. That's not possible. That's not possible. But you're right. There is a problem. I've got 2 chlorines on this side, and I've got 1. The first rule I ever taught you in chemistry was law of conservation of matter and energy. Can't create or destroy things. Can't create or destroy matter and energy. I just destroyed a chlorine if I leave it this way. So that's why there's a 3rd step. And what do you think that 3rd step's going to say? What do I have to do to this equation? I have to balance it, exactly. I have to balance that equation. And you don't balance it by changing the rules. You don't balance it by changing how you would have written sodium chloride. You balance it with something called coefficients. And a coefficient is the same thing it is in math class. A coefficient goes in front of a number in math class, right? And that's where it goes here. It does not change the subscript. So you balance the equation. The number of atoms on both sides still has to be the same. And we're going to use coefficients to do that. So let's do that. Let's take it 1 atom at a time. And I'll go back to blue to do this. Who's not right up there? Is sodium okay? Is sodium all right? Yeah, there's 1 sodium on this side of that yield side, and there's 1 sodium on that side. He's okay. Who's my problem? Chlorine. I got 2 on this side, I only have 1 on that side. So what do I have to do? I can only use coefficients. And I have to put the coefficient in front of the entire compound. So I'll put a 2 there. Notice I didn't put it in between the Na and the Cl. I can't do that. I can't break him up. But I can make 2 salts. I can make 2 NaCls that will give me twice as many chlorines without changing the fact that each sodium and each chlorine lost and gained the proper number of electrons. Now, did that mess something else up in the process, though? Yeah, now there's 2 sodiums, so what do I have to do? Put a 2 in front of there. Is everybody balanced now? Yeah. I've got 2 sodiums here, 2 sodiums there. 2 chlorines here, 2 times 1 is 2 chlorines there. You distribute like you always do. That's correct. That's all you have to do. All right? Now, people always have a problem with this. They don't understand. Like, how can you just make up 2? I didn't. Here's what this equation is really saying. It's saying to make salt, here's what you got to do. You got to take twice as much Na, 2 NAs for every 1 Cl2. Put them together and you'll get 2 NaCls. That's what it's really saying. You just had to work it out backwards that way. And that's the correct answer. Now let's try that again, only we're going to do some more specific things and classifying them. Before I do, I want to show you, by the way, you guys just made the same, well, certainly one of them, and would have made the other one if I didn't correct it, mistakes that I'm going to warn you about right now. You guys will make these two mistakes. I call them two rules. There's no such thing. You're not going to find in any textbook these two rules. They're not rules. They're reminders. They're reminders of the things I've seen over the course of the last 25 years people do the most wrong. Here's the first one. Never change a subscript. That's your the most common and the most tempting. Why would I want to change a subscript? Because it will make me not have to balance it. That's why. So, once you've written the compound correctly, don't change the subscripts. Salt was written correctly as NaCl. I can't make him NaCl2 because it suits me today. That's one. You write him correctly. And by the way, you know people, sometimes they hear about this. When I write that, here's what they hear. So you can never use subscripts. Okay. No! I didn't say you can never use subscripts. If you have Al and Cl together, he's +3, he's -1, he gets that subscript. I'm saying this. If on the other side I've got Cl2, I can't just change that to a 2 to make myself happy. That's what I'm saying. You can't change a subscript once it's written correctly. AlCl3 is written correctly like that. That's correct because he's got a +3, he's got a -1. I can't change that because I had two Als over there and just add a 2 in there for no apparent reason. That's what I'm saying. It gets tempting, but you can't do it. All right, second thing, second mistake people make. And it's the one you all did make in the beginning of the last one. You forget about diatomic elements. When they're by themselves, every one of those Brinkelhoff guys have to have 2 as a subscript. They're always going to have a 2 there. All right? If you keep these two things in your heart, you will do well on this test because those are the the two most common mistakes I see. All right? Now, I'm going to talk about, over the course of the next 4 days, it's going to take me 4 days because there's 4 of them, 4 different types of chemical reactions we have. Today, we're only going to do one. And I have a little demonstration for you on it. Okay? 4 types of chemical reactions. Get your common ion sheet out because that's where they all are. They're all on the common ion sheet. You don't, again, have to memorize hardly anything. That last test I thought would be so easy because you didn't have to memorize much. There's no multiple choice, no matching, no true and false, not even any short answer questions in the last test. I was wrong. You guys managed to screw it up anyway. I had very little memorization on the last test. There's even less memorization on this test. Even less. Because look at the middle of that sheet. The 4 types of reactions. We all have that out, right, Marvis? Where's yours? You lost yours. You got to have to print one out from the internet or borrow somebody's make a copy. Look at the common ion sheet in the middle has the 4 types of reactions right there. What's the first one called? Look at your sheet. Nope. What's the first type of reaction called, Jared?
Composition.
Composition reactions or synthesis reactions. That's the first kind. Write it down. Keep those sheets out. You're going to talk about it a little bit. First type is called synthesis or composition reactions. And you notice next to each of these, what's the next type there, Josh? As you go down. Josh, hello. What's the next kind? See, it helps if you know what we're talking about, not just writing it down.
Decomposition.
Decomposition. See, we got composition. We have decomposition. What's the one underneath that? What's the next generic type of reaction you have underneath that? Emily?
Replacement reaction.
Replacement. And then there's underneath that double replacement. Okay, so or exchange reactions. Those are the 4 major types. There are others, and your book has a few other ones in there too. But we're going to concentrate on these 4. Okay, and if you can do these 4, they're right there in the middle of the sheet. Notice the first one I told you is going to be really easy. I'm going to do this one today. Tomorrow's, or actually later, the second periods today, are decomposition. How many decomposition reactions do you have underneath there? 6. They're going to take me a little bit more time. And then the replacements are even more confusing because there's like 1, 2, A, B, C, 3, 4. There's a lot of different kinds. But today will be easy. I'm only doing composition, and they look like this. Take a look up here. General formula, A plus X yields AX, where A represents some element, and X represents some other element, and you put them together, and you make a compound. That's it. Now, this may sound strange to you. I'm going to say it today, but it really won't make sense to you until probably sometime on Monday. You know what the hardest part of this problem is? The hardest part of these problems is telling what kind of reaction it is. It's not going to be balancing the equation. It's not going to be writing the formulas. You should be pretty good at that by the time we get there. You already should be pretty good at writing formulas. The hardest part of these problems is figuring out what kind of reaction it is for you guys, for some reason. And I'll explain why. It won't make sense right now because they're only, going to be too easy, the first ones. But by the time you get to Monday and Tuesday of next week, it will make sense why it's hard. All right, let me do an example of this. I have a little demo for you to do with this. Okay? Now, I want to take some iron. And I'm going to call it iron 3 just so you know what the charge is. But the fact is you wouldn't know that ahead of time. All right, but I'll call it iron 3 over there. And I'm going to add oxygen to it. Now, I've already done this. You've already seen this. What do we call, if I show you, put the lights on for a second there. What do we call iron oxidizing? Rust, sure. All right, this is an old bottle right here, same stuff, and it sits back in my stock room. This is a newer one, and it's starting to rust, but not quite as bad. But look at how bad that one is. This was like from 1990 something, 94. Okay, so this is from 94. Were you born in 94? No. Wow. So this is older than you. This is how rusty you're going to look. All right. Now look, that's all rust is iron combining with oxygen. So you can see that. But I want to make it go faster. So how could I make some iron, which I have in steel wool? There's mostly iron, right? How could I make it? What do you think I can make it go faster? How can I do it? Heat. I can heat them up. Okay. Watch this. Mr. Phil's going to come in and watch this. Come here, Mr. Phil. Come on. All right. We're going to make this guy heat up. I'm going to light my burner. Watch this. Check this out.
Make this guy heat up.
Watch this. All right. Turn that light off now. This is kind of cool.
No, I don't like the dark.
Okay. No, turn it off. Hurry up.
Seriously?
You ready? Watch. Ready?
I bet it burns.
Yeah. See it?
Oh,
Pretty cool, huh?
that's amazing.
All right. If I blow on it, notice it burns a little bit better. But that's not good enough. We're going to kick it up a notch. I've got in here.
It's like emeralds.
Yeah, that's right. I'm like hemorrhoids? I'm like
Emerald.
emerald. Oh, okay. I'm also like hemorrhoids, and that I'm annoying. But probably more like Lagasse. All right. I have in here. What do you have a bottle of? What do you think that is? Not air. Oxygen. I'll show you how I made it after I do the little demo. I have a bottle of some pure oxygen in here. So we're going to kick it up an even bigger notch when I combine iron and oxygen together.
How long is this going to be?
Right now, it's done. Check this out. Well, I got to do this one on the thing here, though, so that we're on tape right now, by the way. So the folks at home can see this. Okay, you ready? I better stand in front of it like this, I think, too. All right, got to get them hot, and then I'm going to put them in here. Wait, loosen the top up a little bit. You ready? Okay, burns a little bit better there, huh? Isn't that cool?
No.
I think it's cool. Okay, you put the light back on.
That's it?
All right, that's it. No, just okay, it's really hot now. Okay. Now what am I gonna do? I can't take it off of there.
Was there link on the results?
Okay.
It burned.
It burned. Actually, we do have to write the results. Watch this. This is the coolest thing. Watch, Mr. Phillips. You're not paying attention. Don't make me write you up. Look it. Put the light off again because you got to have it off for
Iron
this.
3.
Iron 3 plus oxygen yields, what do you think?
Iron oxide.
Iron 3 oxide? Watch. It's going to burn. That's how it is. See? That's right. Iron 3 plus oxygen, iron 3 oxide. Now, I want you all to try to do that one on your own. You can hit that backlight on, please. Thank you, Mr. Phelps, for bringing those shoes.
I'm going to tell everybody about that. That was awesome.
It was pretty awesome. All right. So, try it right now. You're going to watch for those mistakes I warned you about. Finish this guy up, and he is a harder one to balance. Write each of the formulas correctly underneath, and then try to balance it. Emily, stop picking your tooth.
I wasn't picking a tooth, I was just like,
You're wiggling it, aren't you? Remember when you were a kid and you had a loose tooth, you could wiggle it?
like you just said.
Oh, yeah.
You don't remember that?
Yeah.
I do.
I just woke up.
What?
Probably swallowed it. It was a tooth fairy. All right, come on.
Yeah.
Finish this guy up.
I never remember the tooth fairy taking it out of your mouth, though.
No. There really isn't a tooth fairy. Didn't want to, bring this up today.
What?
I know. Santa Claus too?
What?
What? Hey, you're on
What?
camera. You're on
Don't say
camera.
Oh my God, we're on camera. No! I was just kidding, kids.
What if some sister or brother walking during
Yeah, how about it?
watching it? Yeah, hey, everyone knows that Mr. Allen likes appletini.
Apple teenies. There you go. Thank you, Booklet. All right. Okay, you got that one done? I don't think you do. I don't think you got it right either. Let's see. I'll bet y'all find some mistakes on here. Let's try it. First of all, very first one, I bet you got a mistake. Iron 3, I'm sure at least somebody out there wrote this. That's wrong. Iron by himself. I know I wrote the Roman numeral 3 so you know what to have in the answer. But the fact is, iron by himself, if he's by himself, doesn't have a charge. What's his charge? 0. Okay, so you would just write Fe. You don't have to write the 0, you just write Fe. And I'll bet you some people forgot, even though just 10 minutes ago I reminded you about it, oxygen is diatomic and therefore O2 and not O. And there you go. I see we're erasing again. So for both of those reasons, we've already got mistakes. Even if we do this one right, though, and we get this answer, we still have a chance for 2 more mistakes. It would be nice if this just gave me FeO2, but it doesn't. It doesn't, because that's not the correct formula for iron 3 oxide. Let's erase it and do the correct formula for iron 3 oxide. What do you think? Fe has what charge? +3. Now he does have a +3. He's losing 3 electrons to oxygen, who has a -2. Now, I don't understand why you couldn't do this in the test yesterday, for some of you. It was shocking to me, because we did formulas, not just 3 weeks ago when we first taught it, but every day in order to do the next step, we had to write the correct. I kind of did examples of it all the time. A 2 there and a 3 there, right? Now, the last problem with this one, and it is a tougher one to balance than the last one. How do I balance this guy? I got 2 Fe's, I've got 1 over there. I've got 2 O's, I've got 3 over here. Which one of them's harder to balance? The oxygen, right? So let's take care of him first. I've got 3 O's over here and I've got 2 there. I'll just change that to a 3. That makes my life a lot easier. Can I do that? No. I can't change subscripts. If I change it, it's no longer oxygen, it's ozone actually. But anyway, what will I do? If I've got 2 there and 3 there, what am I going to need? I can only use coefficients now. A 3 in front of here will give me how many O's now on this side? 6. What will I need in front of this guy? A 2. Look where I put him. Right there in front of the whole compound. Not in between. That's just as bad as changing the subscript. That gives me 6 oxygens. But in the process, I messed something else up. What did I mess up? The iron. The O's are fixed. The iron's messed up. So I need a 2 here? No. What do I need? I need a 4. Because I've got 2 times 2 is 4 Fe's over here. I'll need a 4 there. And that is how you do a simple synthesis or composition reaction. Now,